Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This is the 5th installment in the Adventures with Python series, in which we learn Python by building a text adventure game. No prior programming experience is needed, but you should watch the series videos in order. I'll link the playlist here and in the description. Let's get started. In the last video, we learned about loops, and we wrote several conditional or while loops. One of those loops allows the player to explore our dungeon until they choose to quit. I thought that this week it would be fun to go on an iterables side quest. We'll start with for loops, then explore the idea of an iterable, and finally we'll see a quick and powerful way to create lists with list comprehensions. Most programming languages have two basic kinds of loops, conditional loops and counting loops. I've shown you conditional loops. Conditional loops execute while a condition is true. For example, while the user hasn't chosen to quit, as in our shabby abby v4.py program, or while a counter is less than a threshold value, as in our generate_exit_string.py program. And before you think I've shortchanged you by showing you only conditional loops, you can get by with only conditional loops. They're very powerful. A counting loop is not quite as powerful, but it's often a little easier to read. Doing something a specific number of times is such a common use case that most languages have a whole separate construct for doing it, called a for loop, and Python is no exception. So let's begin with the for loop, a counting loop. Our game loop is not a candidate for a counting loop because we don't know how many times it's going to execute. We don't know how many commands the player is going to type before they type a quit command. So we need a conditional loop there. But both of our loops in the generate_exit_string.py program execute a specific number of times. So these are good candidates for a counting loop. Let's look at a simple example first so we can focus on the syntax and structure of a for loop. I'll create a new file and call it list_directions.py. I will add our list of direction strings and call it directions, and a variable I that I'll annotate as an integer. We know that we can write a while loop that will print each value in our list by writing I = 0 while I less than len directions, print directions sub I plus equals 1. And if I run that, it prints each value in the list, 1 to a line. This is a good candidate to write as a counting loop because it's being controlled by a variable, I, which is taking on a predictable sequence of values. It's counting. Every time we run this program, I will take on the values 0, 1, 2, 3. If we increase the size of the list by adding the strings up and down, it will then take on the values 0, 1, 2, 3, 4, and 5. We can say that generally it takes on the values 0 through the length of the list minus 1, which is knowable at the time that the loop executes by using the len function, no matter how long the list is. Let's rewrite it as a for loop. I'm going to show you two different ways. First, I'll recreate our while loop as a for, and I'll comment out the existing loop. In this first version, I'm going to write a for loop in which the loop control variable takes on the values of the indices of the list. I'll write for I in range len directions, colon, and then indented print directions sub I. Now, why is this better? It is shorter, 2 lines instead of 4. But as I've said before, shorter isn't necessarily better. It's better because I have all of the information about how many times this loop executes in the loop header. In the while loop, that information is spread across 3 lines. The line I = 0, that gives our loop control variable its initial value. The line while I is less than len directions, which tests whether we'll enter the loop, and the line I plus equals 1, that updates I so it counts up and has a new value the next time we reach the loop header, until the condition is finally false. In the for loop, all of this is done in one step with the range function. The range function is generating the next value for I each time we reach the loop header. So to understand this loop, you need to know how range works. Let's explore it in the console first. I'm going to write for I in range 10 print I. And when I press enter, we get the values 0 through 9, 1 to a line. Range 10 generated 0 through 9. I'll press Alt-P to get that back, and change it to range 5. Can you predict what will happen? It prints 0 to 4. So if I pass one number as an argument to the range function, range will generate the values from 0 up to, but not including that number passed as an argument, in increments of 1. Now the second way to call it is to pass in a starting value and an ending value. What if I want to count from 1 to 9? Then I'll write range 1, 10. And you can see I get the values from 1 to 9. What if I want the values from 5 to 10? Do you have a guess? It's range 5, 11. Remember, range goes up to, but not including, the end value. The third way to call it is to pass in arguments for the starting value, the ending value, and the amount to increment each time. So if I want to print from 2 to 20 in increments of 2, range 2, 21, 2. The final 2 is the amount to add to I each time. So that's our crash course on range. I suggest you practice with it a little in the console. Try generating odd numbers from 1 to 15. Count down from 10 to 0. And count from 1 to 95 in increments of 5. If you pause the video and do that, when you come back, you'll see my answers, although there's more than one way to generate many ranges. So if you got the correct values, your range was fine. Back in our program now, you can see I'm calling range the first way, by passing in one value, which is the stop value. Range will generate from 0 up to but not including the stop value in increments of 1. So I pass in the list's length to have range generate the indices of the whole list, 0 through length minus 1. And then I can use the loop control variable to index into the list, just as we did with the while loop. Now, let me show you the other way we can write this. I know you'll find this simpler, but you need to know how to write a loop that iterates over the indices of a list for many reasons, including when you're working with parallel list. Iterates means to visit each value one at a time. You're about to hear that word a lot. Here's the second way. For direction in directions, print direction. Oh, that's so easy, isn't it? Instead of iterating over the indices of the list, I can use for to iterate over the list elements themselves. So the loop control variable direction, which I should annotate as a string, is not taking on the indices 0 through 5. It's taking on the values in the list. First direction is north, then it's south, etc. To summarize, that's two ways to loop over a list with for. Using the indices of the list, for example, for I in range len, your list here, and then using I to index into the list in the loop body. And the second is for list element in list, and then using list element in the loop body. If you're iterating over parallel lists, or if you want to replace a value in the list as the loop is executing, you need to use the index method. Now let's talk about how for loops work. A for loop relies on something called an iterator. An iterator is an object that can produce values from a collection, one at a time, in order. You can think of it like a bookmark in a list or another kind of container. It starts at the beginning and, each time you ask for the next item, it returns that value and moves the bookmark forward. Once it reaches the end, it signals to the for loop that there's nothing left, and the loop ends. A for loop will work with any kind of Python object that will return an iterator to iterate over itself. We call objects that you can iterate over iterables, and we've just seen two, a range and a list. A string is also an iterable. In the console, if I type for ch in hello world, print ch, the string will return an iterator that yields each character in the string one at a time. In a future video, we'll see yet another iterable, a dictionary, and with knowledge of classes, you can write your own custom iterables. So you can write your own data type that works with a for loop as if it were a built-in type. Let's rewrite the two loops in generateExitString.py as for loops. I'll rename the program as generateExitString4.py. Each of these loops uses a variable taking on a predictable sequence of values, with the variable given an initial value just before the loop header and the variable updated at the end of the loop after the loop body has executed. That's just how a for loop works, so that's perfect for converting to a for loop. We just need to look at the values that the variable starts at, ends at, and increments by. The outer loop is controlled by the variable test_num. It's given a value of 0 on line 49, just before the loop header. That's its start value. The test is test_num less than len abby, so len abby, whatever length that list is the for loop control variable's end value, or one beyond the end value, which is how range works. And the updater is test_num plus equals 1, so it's incrementing by 1 each time. Because a start value of 0 and an increment of 1 are the defaults, I can change this to simply for test_num in range len abby, and remove the initializer, test_num equals 0, and the updater, test_num plus equals 1. Now, let's look at the inner loop. Pause the video and see if you can convert that to a for loop before I do it. Okay, ready? We have a loop control variable I that starts at 0, ends before len exits list, and is incremented by 1. So I can replace that with for I in range len exits list. That's it. When I run the program, it works exactly as before, but the loops are a little shorter and easier to read because all of the control information is included in the loop header. You only need to read the loop header to see how many times these loops execute and what values the loop control variables take on as the loops execute. Now let's look at that quick and powerful way to create lists that I promised. On lines 53 to 56, we have a loop that is constructing a list from another list based on a condition, which happens to involve a third list. Python has a shortcut for creating lists from other iterables called a list comprehension. The structure of a list comprehension is new list equals open square bracket, expression for item in iterable if condition, close square bracket. The list comprehension builds up a list consisting of the values expression takes on as the loop executes under the optional condition. I'm going to show you some examples in the console, but I'll collect them into a file called comprehensionexamples.py and upload it to my GitHub repository with the other code for this series. There's a link in the description. Suppose I have doubles equals open square bracket I times 2 for I in range 10, close square bracket. This list comprehension has no condition. The condition is optional. The expression is I times 2. Those are the values that will be put in the list doubles. But what is I? I is going to take on the values returned by for I in range 10, so 0 to 9. Therefore, doubles will be a list consisting of 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. The equivalent code without a list comprehension would be doubles equals the empty list for I in range 10, doubles dot append I times 2. You can see you would need to create an empty list, write your loop, and append your expression into the list. Hopefully you can see that the list comprehension is really just a syntactical rearrangement of some code that hopefully already makes sense. Let's add a condition to our list comprehension. We'll only double even numbers. Doubles equals I times 2 for I in range 10 if I mod 2 equals 0. And here's a quick refresh on the mod operator, written as the %, if you need it. Mod returns the remainder of an integer division. If I mod by 2, I get a remainder of 0 if the divisor, in this case I, is even, and I get a remainder of 1 if the divisor is odd. That yields the list 0, 4, 8, 12, 16, the doubles of the even values in the range. Of course, I could have also written the range to have a step of 2 to get the same result. The equivalent code without a list comprehension is doubles equals the empty list for I in range 10 if I mod 2 equals 0, doubles dot append I times 2. Now, let's convert our loop with a condition to a list comprehension. Pause the video and see if you can basically do this in reverse. Ready? Exits equals directions string sub I for I in range len exits list if exits list sub I is not equal to -1. And that is a little long, so I'm going to bring the condition down to a second line. Our list of exits will consist of the values in directions string, but only those for which the parallel value in exits list is not -1. And if we run our program, it runs the same. We've just tightened up our list creation by using a list comprehension, a very Pythonic thing to do. Let's add one more fun Pythonic efficiency to this program, and that's the string join method. The join method starts with a string that is going to glue parts of an iterable together. I have all of my directions in a list, which is an iterable, so I can use join to glue them together with commas, for example. Let's see how it works. I have direction string, which is all of my directions. If I write the string comma dot join direction string, enter, the result is a string of each direction separated by commas. There's no comma at the start and no comma at the end. The commas are between the elements of the list. So for our program, we have the special case of 0 exits and 1 exit, but then for 2 or more exits, we'd like to list the exits separated by commas. So I'm going to remove our elifs for len exits equals 2 and len exits equals 3 and else. And write an else. Exit string equals there are exits to the, and concatenate that with our comma string dot join exits. And then concatenate the period. That's not going to be quite right. I'll show you how to fix it in a moment. But I think that's a little easier to read than the code that's going to give us exactly what we want. If I run that, you can see that the results aren't bad. For example, there are exits to the north, south, east, west. Or there are exits to the north, south, east. Not bad and not incorrect. It's just that we're missing the word and before the last exit. To add that in, what I really want is to join everything except the last element of our list with the commas, and then add in an and then the last element of the exits list. And imagine, again, that we might allow for additional exits like up and down, so the list could be longer. Instead of joining the list exits with the comma, I want to join exits from the start of the list through the second to last element. And so I can join a slice of the list. I know I told you in a prior video that we can use negative numbers to index into a list, and they index from the end of the list. So I can write exits, open square bracket, colon, -1, close square brackets. And that will be the list from the start through the second to last element. And then I'll want to concatenate and then concatenate the last element, which is exits sub -1, and then the period. And if I run that, I get the same output as before. But in the code, we have just one condition for lists of 2 or more elements rather than 3 separate conditions, which would grow with potentially longer lists. In languages without list comprehensions and built-in methods like join, you can use loops to build up collections like strings and lists. In Python, if what you're building is complicated, a loop might be more readable. But quite often, built-in tools like list comprehensions and join are more efficient and thoroughly tested, so they're a good choice if they don't sacrifice the readability of your code. So now you have something new to practice with. Practice writing for loops to iterate over lists and parallel lists, such as the monster stats set of parallel lists I suggested you create in the last video. See if you can write a for loop to create a new list of monsters with hit points over 3, and then rewrite that with a list comprehension. Practice building strings from lists with join. When you're feeling confident with for loops, join, and list comprehensions, join me for the next installment of Adventures with Python. As always, have fun and keep coding.